Hi, welcome to my video on part 2 on functional. This video is on function notation, very important when we're doing the composition of functions or the inverse functions. Here we go. And this is done in the unit on Algebra 1 on relation of functions. So just have an eye to it, look it over, and make sure you know what you're doing, especially with relation to function notation used quite often coming up in my next series of videos. Evaluate each. The f of x equals 4x plus 3. Find the f of negative 1. So normally in math we have an x and a y, but in function notation we have an x and what we call an f of x. Or we could have x and a g of x. This is just different. F of x, g of x, x, and the p of x. It's just different notations, different types of functions. So this is the f of x. So the x is the independent. So the f of x could be treated the same as a y value. So this could be y equals 4x plus 3. So it's a linear function, but we call it f of x. And the reason we do f of x and p of x is only to distinguish the different types of functions so we won't get confused. And you see why we do that as we do the composition of functions, we do the inverse of functions. You see why we're going to use this notation. So find the f of negative 2. So the f of negative 2 means that x is negative 2. Very simple. Negative 8 plus 3 gives you 5. Oh, bad, right? Negative 5. The g of x, this is a quadratic because it's an x squared. What's the g of 2/3? So the g of 2/3 means x is 2/3. So we put 2/3 in the place of x, and we take our time and obey PEMDAS. So in this expression, we'll do the inside of the brackets are done. We'll do the square first. So 2/3 squared is 4/9. And I'm doing just one step at a time. One step at a time. Now that I got the square done, 2 times 4/9 is 2/1. That's 8/9. And 3 into 6 goes 2, so that's negative 4. Add on 7. That's 8/9, make that a negative 11. So the common denominator is 9. So put the 11/1, so we make that a 9. So 9 times 1 is 9. 9 times negative 11 is 99. So we have 8, subtract 99/9. And that gives us a negative 91/9, which is a negative 10 1/9. So I just wanted to put 2/3 in there, do a bit of fraction, just not keep two integers all the time. Number 2, the f of x equals x squared minus 8. Find the f of x minus 3. So we did the f of negative 2, we put a negative 2 in. We did 2/3 and we put 2/3 in the place of x. So why not say the f of x plus 3 is equal to, so the x is being replaced with x plus 3. So we put x plus 3 in the place of x and we work it out. So we got to square this, so it's x plus 3 times x plus 3. So we'll multiply these two. That's x squared. Outside is 3x, inside is 3x, so that's a 6x. 3 times 3 makes 9. Negative 8 times x. Negative 8 times 3. And we add up the like terms. X squared minus 2x minus 15. So you're subbing x plus 3 in the place of x and working out your math. The f of 4x minus 7. Find the f of x plus 1, subtract the f of x. So what's the f of x plus 1? So that means you got to put x plus 1 in the place of x. So 4x plus 1 plus 7. So let's do the square bracket on that. So this is the f of x plus 1 right here. We're putting x plus 1 in the place of x. Now we're going to subtract the f of x. So the f of x is 4x plus 7. Try not to get confused. So we're putting x plus 1 in the place of x. Done. And we're putting, this is the f of x. Done. So we take our time. We have to do inside the brackets first. So this is 4 times x plus 1. 4x plus 4 plus 7. This bracket, you do not need to do anything. And we got to simplify the brackets, so it's 4x plus 11. Subtract 4x plus 7. Notice I got the square brackets used. You could use the oval round brackets. So now we got this binomial, subtract this one. So this is 4x plus 11. And we subtract, we add on the opposite, so that's a negative 4x minus 7. Or we can put a 1 here and go negative 1 times that. The 4x cancels out, and we get 4. Just do something a little tiny bit different. And let's do some more examples. If the h of x is a negative 3x, and the p of x is 2x plus 4, find the value of x if the h of 4x minus 1 equals the p of x plus 3. So, we're putting in the place of x, we're putting, this is 3x, negative 3x. So that 4x minus 1 goes in right there. So that's a negative 3 times 4x minus 1. And x plus 3 is going in the place of the x and the p of x. So the p of x is 2. So we're going to put x plus 3 in the place of x. So it seems odd, but we're putting the x in the place of x, but it's the way we work it. Like if this was a 5, if we did the h of 5, we put 5 in the place of x and get negative 15. If that was the p of 10, I would put 10 in the place of x and get a 24. So just be careful. And we obey PEMDAS. We multiply negative 12x plus 3, 2x plus 6. And what I do, I always like to simplify each side before I transpose. So negative 12x minus 2x, 10 minus 3, negative 14x equals 7. And we divide by negative 14. X is 1, negative 1 over 2. 7 into 7 goes once. 7 into 14 goes 2 as a negative. So we get x is a negative a half. Number 5, if the f of x equals x plus 2, find the value of x, and we just have more expressions. So we got the f of x squared minus 3 plus the f of x plus 1 equals 8. So here's the f of x. So right here, I'll just do this one. We're putting x squared minus 3 in the place of x. So there's x squared minus 3 going into place of x. Plus, I'm doing square brackets to distinguish. Now we're putting x plus 1 into place of x. So x plus 1 goes into place of x, so it's x plus 1 plus 2. So there, I just subbed them in. Now I simplify, I'm only keeping square brackets here just to show you. There it is. So you don't get confused. And by this stage, you're normally not that bad. I mean, you're in pre-calculus. This would probably seem trivial, but just to make sure. So I got the brackets simplified. Now I'm adding. So it's x squared minus 1 plus x plus 3 minus 8 equals 0. X squared plus x. And this becomes 2, negative 6. So 8 plus 3 is negative 5, negative 1. This is a quadratic, and let's see if we can factor it. X squared is x and x. Factors of 6 are 1 times 6, 3 times 2. What pair of factors give you a 1? 3 and 2. And product is negative, so it's a negative and a positive number. So multiply, we have a plus 3 minus 2. Product is negative 6, sum is 1. So that means x plus 3 is equal to 0. X minus 2 is equal to 0. X is negative 3. X is 2. And so those are the values of x that will make this true. Again, if you took the 2, for instance, if you plug the 2 in here, so take the 2 and sub in here. That's a 4 minus 3, 1. So if you take the 1, the f of 1 and sub in here, you get a 3. So that's a 3. Now if you take the 2 and sub in here, you get the f of 3. Put a 3 in here, and you get a 5. So 3 plus 5, 8. So I just illustrate that. There's 2 answers, and one of them is 2. You can check the negative 3. So you take that number, sub in here, because that's what x is 2. Take that answer that you get in here and sub it into right here. And you can see that everything is working okay. And a couple of more to do just to end our function notation, something different questions. If the f of x equals x over x minus 2, and x is not 2, notice it said x is not 2. Because if x is 2, this is a 0 denominator, and division by 0 is undefined. So we're not allowed to have, we can have any other number in this expression, but right now we're not allowed to have 2, because it makes it 0. Find each and state the restrictions. So we're going to find what the f of x minus 3. So x minus 3 is going in place of x. X minus 3 is going into place of x. So x minus 3 went right there, and x minus 3 went right there. You simplify that, you get x minus 3 over x minus 5. So that's what we found. Now what's the restriction? And the restriction is x. So x minus 5 cannot be 0. So that means that x cannot be 5. X, I'll rub that out there. So we cannot have a 0 here. So x minus 5 cannot be 0. That means x can't be 5. Just check. 5 minus 5 is 0. Division by 0 is undefined. So the restriction, so we restricted the beginning one of x can't be 2. And then when we did the map function notation by subbing in, we worked it out to be x is not 5. And now what about f of 1 over y? So we're putting 1 over y is going into place of x. So that's 1 over y divided by 1 over y minus 2. So 1 over y is going right here, and 1 over y is going right here. Now what we have here is what we call a complex fractions. In rational expressions, we did a whole topic on complex fractions. And the fastest way to do complex fractions, that you have fractions on top and bottom, is to find the LCD. So the LCD for your numerator and your denominator. So this is numerator and denominator. So the LCD for the numerator is y. The LCD for the denominator is y. So the LCD for both is y. So that means what I do, quick way, is I multiply the top by y and I multiply the bottom by y. So when I multiply the bottom by y and the top by y, what happens? The y's cancel, I get a 1. Y times 1 over y gives me 1. And negative 2 times y gives me negative 2y. So because I have complex fractions, I find the denominator for top and bottom and multiply the top numerator and the denominator by that LCD. And every denominator should cancel out. So now we have 1 over, and that could be 1 over negative 2y plus 1. We could have it written like that. But whatever we do, we got to say that negative 2y plus 1 cannot be 0. Your denominator cannot be 0. So 1 becomes negative 1 moved over, divided by negative 2. So y cannot be a half, because a half gives me a 0. Okay, just another little tiny review, and we'll finish the function notation. If the f of 2 is negative 1, and the f of negative 3 equals 9, find f of x equals mx plus b. Well, just a little review in that the x comma f of x, we have an x and an f of x. That's the same as we have an x and a y. So if you take the first ordered pair here, we have an x, that's an x, that's the f of x, x is 2. So the y is the f of 2. If we take the second ordered pair, you have x is negative 3, so that's the f of negative 3 is the y. So notice, that's x, that's your y. So if the f of x, that means, if you look at this ordered pair here, that means if x is 2, then a negative 1 is the f of 2, so the negative 1 is your y. We look at this ordered pair here, x is negative 3, the f of negative 3 is your y, that means your y is 9. So that's your x, and that's your y. So if I wrote right here, if I took the f of negative 3 and said, that's y equals 9, like that, because the f of 3 is your y. If I said y is equal to negative 1, so you say x is 2, y is negative 1. X is negative 3, y is 9. So we take those two ordered pairs and do that with it. X is 2. The f of 2 is your y. If x is negative 3, the f of negative 3 is your y. Again, keeping this in line. So we have, notice this is y. So if I wrote y equals mx plus b, you'd say that's a linear. That's the slope and that's the y-intercept. So we need the slope. The slope is, this is x1, y1. This is x2, y2. So the slope is y2 minus y1 over x2 minus x1. So y2 is a 9 minus negative 1. x2 is negative 3 minus x1, which is 2. So that gives us, double negative is a positive, so that's 10. And negative 3 minus 2 is negative 5. 10 divided by negative 5 is negative 2, so the slope is negative 2. And now we go y equals mx plus b. So we have y equals negative 2x plus b. That gives us what we know what a slope is, negative 2, so I put the negative 2 in the equation. Now I take any one of these 2 points, it makes no difference. So if I take the point 2 and negative 1, that's x and that's y. So y is negative 1, x is 2, negative 1 equals negative 4 plus b. Leave your b where it is, negative 1 plus 4, so b becomes 3. You could also take this other point. You could take the negative 3, 9 and sub them in like this, and you'll get b is 3. So the equation y equals m, slope is negative 2, and your b is 3. So that's the equation. And we want it like this. The y is f of x. So change the y to an f of x. So check. X is 2. Put a 2 in. Put a 2 in here. Negative 2 times 2 is negative 4. Negative 4 plus 3, negative 1. Take it. X is negative 3. Put a negative 3 here. The f of negative 3. Negative 2 times negative 3 is 6. 6 plus 3, 9. So that's the right function notation, or the right equation that represents these two ordered pairs. And what's the name of this? The name of f(f) is called a linear function because it's a line. If you graph this line, what will it look like? Well, the y-intercept is 3. If you let x be 0, if x is 0, y is 3. F of x is a y. X is 0, y is 3. If x is 1, then y is 1. Put a 1 in here, you get negative 2 plus 3 is 1. Or, think about it, if you're, well, we know it's a line, so if x is, if the y-intercept is 3, this is negative 2 over 1, so we go down 2, right 1. Down 2, right 1. So there's the line going through that point there, going to this one. That's the line that represents this relation. Again, it's just review on the function notation because we're going to need that in the problems, videos that we're going to do. And again, if you like my video, click the like button, click the subscribe button. If you wish to be a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.